Hey guys, welcome back. So today we are looking at 1.6, something to chew on. So in this, we're really going to be taking a look at our arrhythmic sequences, so really working with those. So let's go ahead and jump on in. Now I'm going to be doing most of these on the whiteboard, so we'll just look at the directions and everything on the screen, and then I'll take and bring this back up. So for the first part, we're finding the missing terms for each arrhythmic sequence and stating the common difference. So we are going to look at number 4 together. So on number 4, we're going from 0 to blank. We've got another blank, then we've got 2, and then we have 8/3. So we need to figure out what the common difference is first and foremost. So where we should start with this one, because obviously we're going from 0 to something. We have no idea what we're going from there. So the two numbers that we're really looking at to compare are these two right here. So we have 2 and we have 8/3. Now, looking at that, most of you are probably panicking, going, oh my goodness, I don't know, I hate fractions. Don't panic. We just need to convert the 2 into a fraction. Being as we're dealing with thirds, it would take 6/3 to equal 2, because 6 divided by 3 is 2. So really, instead of having 2 and then 8/3 to worry about, we're looking at 6/3 and 8/3. So what happened? How did we get from 6/3 to 8/3? We went up by 2/3. Now, some of you may have said 2. We did not just go up by 2. If we added 2, it'd be a lot more. It'd be 4. So what we added was 2/3. So our common difference is 2/3. So that means from 0 to our first blank, we're adding 2/3. So we're going to get 2/3. From our first blank to our second blank, once again, we're adding 2/3. So 2/3 plus 2/3 is 4/3. Remember, in order to take and add fractions together, you have to have a common denominator, but the denominator will not change when you're adding. Only the numerator will. Okay? All right, so that's what you guys are looking at for 1 through 6. Now, this is the only one that has fractions, so I did that one with you so you didn't have to take and worry and stress so much, but that's what you're looking at. So you only really have 2 numbers in each case that you're going to be finding your difference for, but I will tell you, we are only adding on these. So there's not going to be any multiplication. So if you're going from 6 to 12, you're not multiplying by 2, you're adding 6. So keep that in mind. This is all arrhythmic functions. So we don't want to have any multiplication in going from one term to the next. With that being said, your keyword for this lesson is arrhythmic. All right. So the next section, we want to find 2 consecutive terms in another arrhythmic sequence. In an arrhythmic sequence are given. Sorry, I cannot read. 2 consecutive terms in an arrhythmic sequence are given. Find the recursive function. So we're looking at number 7 on this one. So it says if f of 3 equals 5 and f of 4 equals 8, we need to find f of 6 and f of 5. So we need to find the next 2 terms. That's all that means. This is telling us the f of 3 equals 5. That just means the third term in this sequence is 5. The fourth term in this sequence is 8, and we need to find the 5th and 6th terms. So don't panic over seeing the f of 3, f of 4, f of 5, f of 6. All that's telling you is what term number we're looking at. So how do we go from 5 to 8? We added what? What do we have to add to 5 to get to 8? 3. So our recursive equation is now equals previous plus 3. And I've had a few of you ask me about this. Do I really have to write out the whole now equals previous? So long as you know what the n and p stand for, I'm fine with you doing n equals p plus 3, because this represents now equals previous plus 3. So if our fourth term is 8, and we add 3 to that to get to our 5th term, what should our 5th term be? 8 plus 3 is 11. Then our next term, we're just moving to the 6th term. We are at the 5th term. We add 3. 11 plus 3 is 14. So our 6th term is 14. So that's what these are like, okay? So you're still 1 through 9. All of these are all arithmetic sequences. So that means there's no multiplication to go between them. Now, I'm going to go back to this. So you'll be doing the same thing on 8 and 9. You figure out what do you have to add to get from one to the next, or subtract, depending on the situation. Now, the next set of problems, make note, geometric, which means we are multiplying. So we're going to look at number 12 on this one because obviously there's some crazy decimals going on in this. So I figure you'll be more comfortable if we do that one together. Now, we have that the fifth term is 20.58, the sixth term is 2.94, and we need to find the seventh and eighth terms. Now, you're probably wondering, how on earth do we get between these? What are we adding or multiplying? And being as it's geometric, you should be multiplying. So how we find this is by division. So what you're going to do is you're going to take 2 94/100 and divide it by 20 58/100. So divide these and you will take and find what your multiplier is. So if you divide those two things, 2.94 divided by 20.58, you're going to get, I'll tell you exactly what the calculator will say, because it's going to be a decimal, I will tell you. It's going to look like this big, long, ugly decimal. So if you can see, maybe, oops, that showed you the fraction version of it. So you can kind of see that big, long, ugly decimal. That big, long, ugly decimal, if you have a calculator that will switch between fractions and decimals like I do, which I suggest having this kind of calculator, you'll find out that what we're multiplying by is 1/7. So our recursive equation now equals previous times 1/7. So essentially, you're just dividing by 7. So to find our seventh term, we're going to take 2.94 and we're going to divide it by 7. And we end up with 0.42. Then for the eighth term, we're going to take 0.42 and divide it by 7. And we're going to get 0.06. So, like I said, that one's going to be the hardest because it was giving you some crazy looking decimals and you were dividing by 7 / multiplying by 1/7. So that isn't something we're used to having to do. So it definitely looked a little more confusing than it needed to. But it's all for 10 through 12. So 10 and 11 for what you have to do. You are multiplying or dividing, not adding and subtracting because those are geometric. All right, and the last section that we're looking at today is finding the indicated values of f of n. So we're given different f of n functions, and then we're given two values that we need to find. So every single one of these, except for 17, obviously, because it's different, but every single one of these, you should have two answers because there are two over here. So we've got f of 5 and f of 0. You need to find two different numbers, f of 4 and f of 1, two different numbers, okay? So make sure you have two answers for those. So we're going to look at 13. 13 is f of n equals 2 to the power of n. So we're going to find f of 5. So f of 5 equals 2 to the 5th power, because remember, all this 5 over here means is wherever we see an n in the equation, we're plugging in a 5 for it. Now, 2 to the 5th power. So 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. There's your 2 to the 5th. So 2 to the 5th is 32. Now, we need to do f of 0. So f of 0 equals 2 to the power of 0. Now, 2 to the power of 0, anything to the power of 0, is automatically 1, not 0. When we're taking exponents, 0 does not just mean your answer is 0. It means it's 1. So keep that in mind. All right, the next one we're looking at. So these were exponential. This is linear. Same idea though. We still have two things we're going to plug in. So f of 5 is going to equal 3 plus 4 times the quantity 5 minus 1. 5 minus 1 is 4. So we're going to get 3 plus 4 times 4. 4 times 4 is 16. And 16 plus 3 is 19. There's our answer. F of 5 equals 19. So a little bit more work on these. Now, f of 0 equals 3 plus 4 times the quantity 0 minus 1. 0 minus 1 is negative 1. 4 times negative 1, negative 4. 3 minus 4, negative 1. So be very, very careful with your negatives. A lot of you on some past assignments I've been grading have been accidentally dropping negatives or not multiplying your negative through and just kind of dropping it out. Do not do that. It completely changes your answers. Some of you are learning when you're getting them wrong. Okay, if you guys have any questions, feel free to ask. Remember, your keyword is arithmetic, so make sure you get that submitted. Like I said, if you have questions, feel free to ask. Have a great day, you guys.